Good morning, advanced math kids. This is Miss Lefort, and this week we are studying factoring. So we're going to start off with factoring the polynomials, looking for a GCF, because that is the very first thing that you need to look for. So when you're factoring polynomials and you're looking for a GCF, we're just going to do several examples here today. Let's see, number one, you can just write these down yourself. 70x minus 80. So yes, you should take notes and work these out with me. So if this is our problem and we're looking for to factor it, notice that there's only two terms, so this is a binomial, and we need to factor out a GCF. So you have to figure out what does 70x and 80 have in common that you can take out. And yes, you are correct. We could take out a 10, and if we divide that by 10, then that gives us 7x minus 8 on the inside. Now, if you see that already, that is wonderful. Some people need to write the step where they're like dividing it by 10, but just be sure and keep the 10 with your answer right there. So if you need to write that step, that is fine, no problem. Okay, so another example. What if we had just like, say, 32 plus 40x? Again, I'm trying to do some basic ones first. So you would essentially divide by, what do they have in common? That's 8, I think, right? I can divide them both by 8. So then, of course, I would keep my 8, because I'm factoring out that GCF of 8. And if I divide those out, that gives me 4 plus 5x. All right, let's keep going. So notice on number 3, let's do 8x cubed minus x. So notice how on the first two we had a GCF of just a number, whereas on number 3 we've got a GCF of just a variable. So what do they have in common? They both have an x in common. So we are going to divide by the x that they have in common. But we got to keep it, it stays in the front there. So if we divide that out, we get 8x squared minus 1. So be real careful about the the 1 right there. A lot of people tend to not want to put that. I don't know why they think it maybe is 0 or something, but it's not. So you do keep everything there. So x over x would be 1. All right, here's number 4. Number 4, let's put numbers and variables in common. So what if we had, oops, I'm on the wrong thing here, 60x to the 9th plus 54x to the 3rd. So when you're looking at those two, what is it that they have in common? Well, if you're looking at the numbers 60 and 54, they both have a 6 in common. If you look at the letters, this would be 3 x's in common. So we're going to divide by 6x to the 3rd on both of these. And of course, you got to keep that, right? 6x to the 3rd, that would be in the front. And then this would be 10x to the 6th plus 9. Alrighty, let's see if it'll let me slide up. It does, great. Okay, so number 5. Let's do another one like that one. What if we had negative 81x cubed minus 36x to the 5th? So notice this one I did with the negatives. If you have negatives in both places, yeah, you certainly can take out a negative. So when we're looking at these values, 81 and 36, 9, right? Would that be 9? So they both have a negative, so I'm going to do negative 9. And the most I can do is x to the 3rd, because that is the most x's on there that they have in common. So I'm going to keep the negative 9x to the 3rd. That's what I'm factoring out. And then when I divide this out, that leaves me with 9, and then that's a plus what is that, 4x squared. All right, let's keep going. Another example. Okay, I'm trying to make them a little bit harder as we go so you can see the more challenging ones too, because you're going to have a mix of these on your assignment. So on number 6, we have x squared y cubed plus y to the 4th. So now we're adding in more letters. So let's see what they have in common. If you notice, they both have y's in common. So we're going to divide by y to the 3rd because that's what they have in common. So y to the 3rd, let's see if I do that. That one all cancels out, so I'm just left with x squared. And on the last one, I just have one y left. Well, that one wasn't too bad. All right, number 7, x y to the 4th minus y. So let's see, what do they have in common? Oh, just a y. Yeah, just one y. Okay, so this would be, if I take out the y, I'm left with x y to the 3rd minus 1. Again, pay attention to that little 1 right there. A lot of people tend to forget it, but you do want to keep that. All right, moving right along. Number 8. X cubed y squared plus x to the 4th y squared. All right, let's see. What do they have in common? What is our GCF? Well, they both have an x and they both have a y, but we can only take out what they have the most. So let's see. That would be, as far as the x's, 3 x's, right? It's the most I can take out because that's what they have in common. And then, oh, y squared. Sweet. They both have a y squared. All right, so this means we would have x cubed y squared. And this would be 1 plus x. So again, just be real careful with that 1. A lot of people tend to forget it, but it does belong there. All right, let's do another one. Let's up the ante a little bit. Let's make this a little bit more challenging. What if we had negative 18 y cubed z plus 48 x to the 4th y to the 4th z to the 4th. So when we're looking at this, what do they have in common? Let's see. 18 and 48. Let's see, that would be 6. And I could take the negative out or not. It really doesn't matter. That would be a 6. And then as far as the letters, y to the 3rd and z is all we have. So I'm going to write this on here. I'm not going to take out the negative because it's not in both. But if you did, that's fine. So I'm going to divide by 6y to the 3rd z. 6y to the 3rd z on both of those. So then that gives me, well, I got to keep my 6y to the 3rd z. And inside, let's see, that would be negative 3 plus 8. Let's see, x to the 4th, because none of those cancel. 1 of the y's, and then 3 of the z's. All right, very good. Let's do another one. Number 10, negative 30 y to the 5th z minus 48 x to the 3rd y to the 3rd z squared. Is that the same problem? It's almost the same problem. Yeah, it's almost the same exact problem. Weird. Anyway, not a big deal. Let's do it. Okay, so what do they have in common? This one does have a negative with both, so I'm going to take the negative out. This would be 6y to the 3rd z. Negative 6y to the 3rd z. Yeah, it's funny that's the same GCF. Okay, so this would be a negative 6y to the 3rd z. And then what would be left over? If I divide that out, that would be 5, a positive 5, y squared The z's go away. Okay, so then the positive 8 x to the third z. So notice how the answer is different, but the GCF happen to be the same, sort of. So anyway, there you go. There's a lot of GCFs. You have to look for those first. Now, the other thing I want to point out today that we're looking at is factoring polynomials when you have a difference of squares. So do you remember the difference of squares? You should. Difference of squares. And that's when, gosh, my handwriting is terrible. That's when you have a perfect square minus a perfect square. So you learned it in Algebra 1, probably a squared minus b squared. And when you factored it, it was a plus b times a minus b. This is what you should have seen. You just got to recognize it. So like on number 11, if you had 1 minus x squared, then you remember 1 is 1 squared. So this is 1 plus x times 1 minus x. That's how it factors. If you had one like, say, 49 minus 144x squared, 49 is a perfect square, 144x squared is a perfect square, so this would be 7 plus 12x, 7 minus 12x. So you just got to be able to recognize that pattern. So if there was a GCF first, we would factor that out, of course, but if not, we're just looking at that. Oh my goodness, I'm at the bottom of the page. Let me go to a different page. Okay, so a couple more examples on the difference of perfect squares here. Let's do number, oh, I got 14. That's not 14. That's 13. Okay, so, all right, so number 13. Let's do, what if it was x to the 6 minus 49 y to the 6? And a lot of times people don't realize that that's perfect squares, but basically any time that that exponent is an even number, they are perfect squares. Okay, so this would go to x cubed minus 49. Oh, I'm looking at the wrong one. Let me fix that. X cubed, and of course my dog's going to bark now. This would be 7y cubed, 1 plus and 1 minus. So notice it's a plus minus of the same thing. So like on 14, we'll give you another example. What if you just had y squared? Oh my goodness. I don't know why that dog's barking. Y squared minus 144x squared. This would be y plus 12x, y minus 12x. So you just have to look for the perfect squares. If they're even numbers, just divide those exponents by 2, and then you have it. All right, so from now on, you'll be working on a Delta Math assignment that says today's thing. So go to your Delta Math and do that assignment, and hopefully you'll do great. And if you have questions, let me know.